All right. So the problem that we have is that we have to compare the two amounts. We have to compare the difference between the simple interest account and the compound interest account. And we have to do it over 10 years, which means that we need to do it with a table. So if we do it with our CAS, then what we can do is we need to actually create the equation. So the simple interest formula is SI equals PRT over 100. And then the amount is equal to P plus I. So it is going to be, in terms of our CAS calculator, Y equals 1200, because that's our principal. A is the amount we don't know, plus I, which is PRT over 100, which is 1200 times its simple interest, so it's going to be 3 times X over 100. All right, so T is the variable that we don't know, so that's there. And then Y is this amount here. So if we now have an equation here that we can cancel down. And if we cancel that down, we end up with so we end up putting into our calculators Y equals 1200 plus 12 times 3 is 36, and the hundreds cancelled out. So that means that's his account. That's what's going to happen. Now, to go to our friend for compound interest, remember that for the compound interest, it is different. All right. Remember that our compound interest formula is radically different to how it is normally, because it is using something that is involving exponentials. All right, so it is going to be a much bigger amount of numbers going on here. So for the record, remember that our formula is equal to A equals P bracket 1 plus R over 100 to the power of T. All right, so P bracket 1 to the power of R over 100 to the power of T. So A, again, we don't know, so we'll call that Y. P is 1200, bracket 1 plus R. So because we're doing compound interest, we have to use the compound interest amount, which is 1.5. And it's to the power of X, because we do not know the years. So the years are going to be different. So this is going to be our equation 1, and there's our equation 2. So that's what we're going to put into our CAS. So we now have two equations that represent the problem at the start. So what we will do is we'll grab our good friend Mr. Kaz. And we'll get a little bit bigger. So, on our Kaz, what we're going to do is we're going to go to graph and table. I think I'm just going to get rid of all this method stuff. All right, now I don't need to worry about the graph, but what I do need is I need to put into my Kaz, my equation. Y1 is going to be equal to 1200 plus 36x. All right, so that's our first equation. The second equation is going to be the one that we worked out down below. That one there. So it's going to be equal to 1200 brackets 1 plus 1.5 over 100 to the power, using that little up arrow, to the power of x. So they both look about the same. And then I'm going to press the table button. And then I'm going to change how my window looks. So it's going to be, x min is going to be 0, x max is going to be 10, because it's 10 years. And so start at 0, end at 10, and we'll go by steps of 1. And what I now have here is this table here. So they both start off at the same amount. And now we can see how long or how much he's going to earn depending on which investment. So the question is, after 10 years, which account is he better off with? Is he better off with the simple interest or the compound interest? Simple. All right, because if you look at the simple interest account, at the end of 10 years, he's got $1,500 or $1,560. But in the compound interest account, he only has $1,392. So my question to you is, how long do you think it would take for the compound interest account to take over? How long? Probably another 10 years. All right. Or less, maybe. Who knows? So, well, let's add a few more years onto our account. So you reckon 10 years. All right. So let's add on 10 more years. No. After 10 years, still then. Let's do it graphically. Let's use our we've got our graphs or equations, so let's graph it instead. And we'll go to So there you go. I have now graphed my compound interest equation against my simple interest equation, and I can now see that there is a point. There is actually a point where the compound interest account takes over for the simple interest account. And using our CAS, we can actually find where they intersect. After 85 years. So it's going to take 85 years for the compound interest account to overtake the simple interest account. However, after that point, you're much better off having that compound interest account. Who's watched Futurama? Yeah? So there's an episode of Futurama is a show about a pizza delivery guy who delivers a pizza to a cryogenic freezing lab on the stroke of midnight to go to the year 2000. He falls into a cryogenic freezing tank and is frozen until the year 3000. So he wakes up and he's like, stranger in a strange place. There's an episode where he realizes that he only had $2 in his bank account when he went to sleep. But after 1,000 years, he had a lot of money because of the way compound interest works. So, if we, as another example of how powerful compound interest can be, so he had about $2. This is still 14D. So he had $2, and what we do is we then multiply it by 1.0. So let's say it's about 2%, but you compound it for 1,000 years, and that's $2. You had $2 in a bank account. You leave it for 1,000 years at 2% compound interest, and that is $796 million. That's at 2%. At 1%, it's $41,000. Even at 1.5, you're still looking at $5.8 million. So compound interest can get ridiculously out of hand the longer it's left in there. However, that is why they offer it to you at a lower starting rate, because it takes decades for the compound interest to catch up to the simple interest. So we've answered the question. We've had that table made. You would possibly get questions like this that say, well, okay, when does compound interest overtake simple interest? So you can do that with using the solve function. So what we can do is we can go y equals 1200 plus 36x, and y also equals 1200 bracket keyboard and then x comma y. And it tells me there are two answers to the question. One is at 1200, which is what we worked out, but also at the 85-year mark, at which point there would be $4,267. So we can work out exact combinations of values that create multiple answers. So if you don't have your CAS, you can still do this You can still do all this with a spreadsheet. So I'm going to get rid of that window and I'm going to open up Excel. And I'm going to add a window. Increase the size a little bit. So what I'm going to do here is I'm going to have years, simple, compound, and then I'm going to go 0, 1, 2. Just going to drag that down to 10. And now in here, I'm going to put in some reference values. So simple, so I'm going to put in my formula. And the formula is going to be equal sum. It's going to be 1200 plus 36 times A3. And I'm going to drag that all the way down, and it gives me that answer. Compound is a little different. So what I have to do is I have to now go equal sum bracket 1200 times 1 plus 1.5 over 100 to the power of the number there, close bracket, and then drag it down. All right, so we still end up with the same set of questions. And the beautiful part is that what we can also do is we can also customize these to change it. So I can easily go in here, and instead of changing one number, I can go up here. So this says 1.5, and this is 3. Times that times that. Hello, hello. So now what I've done is I've now got this formula here. So if I ever change, I can change the simple interest percentage and it automatically updates everything for me. All right, so I can change in here. I can put the principal in here and change this to be an absolute reference. So what I've done now is I've created a little calculator here that I can change my value, I can change my deposit amount, initial deposit amount, I can change the interest rate, and it will automatically update all the values for me in the table. And then I can do the same for this one here. I just need to do a bit of math stuff. So now I can change these three values, and that will automatically update my table and allow me to compare which deal is better. And this sort of thing might come in useful if we start doing a SAT online and you don't have access to your CAS. We don't know when we're going to have access to our CAS, but this would be something useful for you to make. I'm going to put this spreadsheet up on Compass as well, so you guys have access to it. And it might help you visualize some of these things differently. And the best part is because of the way this works, I can go here and then I can drag it and it will just update everything for me. So I have the compound interest and simple interest worked out for 152 years. No extra effort on my behalf. A little bit of extra setup compared to your CAS, in that you have to use the absolute values, but it will allow you to generate the tables of values much, much quicker.